Hurricane Harvey has already dumped 9 trillion gallons of water on Texas and may leave even more before it backs up to the Gulf of Mexico. Starting as a Category 4 hurricane as it made landfall on Friday night, Harvey, which has since been downgraded to a tropical storm, is breaking weather records every hour, and is leaving some scientists scratching their heads as to why it stalled over South Texas instead of cruising northward to Oklahoma and then to the Midwest as storms of this nature typically do. Is climate change to blame for its atypical path of destruction? Well, a bit, according to climate researchers. Climate change didn't spawn Harvey, or any other hurricane, though it has made them more dangerous. But scientists are careful not to blame all of Harvey's destruction on greenhouse warming. Plus, this is a conditional situation. Houston's lack of rain, sponging green space and devil-may-care zoning laws have probably made things worse as well. The hurricane is a naturally occurring hazard that is exacerbated by climate change, says Catherine Hayhoe, an atmospheric scientist and professor of political science at Texas Tech University. But the actual risk to Houston is a combination of the hazard, rainfall, storm surge and wind, the vulnerability, and the exposure. In Houston's case, vulnerability is particularly high. It's a rapidly growing city with vast areas of impervious surfaces, Hayhoe says. Its infrastructure is crumbling, and it's difficult for people to get out of harm's way. When Hayhoe and other scientists look at the storm itself, they see a hurricane that has been able to keep one foot on the gas pedal while still connected to the gas tank. Warmer water means more water vapor available to power the hurricane, and Harvey's fuel source, the Gulf of Mexico, is unusually warm right now thanks to a combo of slow climate change-related warming and a hot August in the Gulf. As Harvey approached the Texas coast last week, the Gulf Ocean temperature rose 2.7 to 7.2 degrees Fahrenheit above average. That provided a deep, warm pool of water used as fuel, says Dahlia Kirschbaum, a research scientist at NASA's Goddard Space Flight Center who studies hurricane hydrology. Harvey used this hot spot to shift from a tropical depression to a Category 4 hurricane in roughly 48 hours. Long-term, the sea surface temperature of that region has risen about 1 degree over the past few decades, from roughly 86 to 87 degrees Fahrenheit, according to Michael Mann, a climatologist at Penn State. Mann said in a Facebook post on Monday that a relationship known as the Clausius-Clapeyron equation tells us there is a roughly 3% increase in average atmospheric moisture content for each 0.5 degrees Celsius of warming, almost 1 degree Fahrenheit. That means 3 to 5% more moisture in the atmosphere in the Gulf region near the South Texas coast. So Harvey has a big tank of tropical moisture that it has been dumping on land. The storm surge is also made worse by sea levels that are higher than they were decades ago. Thanks to climate change, storm surges today are 7 inches higher than they were 30 years ago, according to a January study by NOAA, though other factors can combine to increase surges even more. By the year 2100, global sea levels will rise an average of 1 to 8.2 feet. But the western Gulf Coast will see an additional rise of 1 to 1.6 feet, according to the NOAA study. Harvey is no average storm. Some have called it a black swan, an outlier, something that only comes along every millennium. Over the weekend, Carrie Emanuel, an atmospheric scientist at the Massachusetts Institute of Technology, looked at the rainfall data from Harvey and did a few calculations on its landfall at Rockport, Texas. He calculated that Rockport would get a foot of rain about once in 1,000 years based on the average climate of the past 38 years. But taken in the context of the past 3 years and recent high temperatures, the odds increased to about once in 250 years. For all of southeast Texas, the probability of getting that foot of rain has increased from about once in 100 years to about once in 25 years. Why the change? First, the Gulf water is warmer. Second, while rainy tropical cyclones like Harvey aren't more frequent, the high-level winds that usually push them out to sea or north to Oklahoma have stopped blowing. We don't know why they have collapsed, says Emanuel, and it's too early to connect it to anthropogenic climate change. But the effects are clear. Emanuel says the collapse of these winds over South Texas started in 2010 and has continued, a time when Houston has been hit by numerous violent and disastrous storms that have flooded the city. For Emanuel and others, figuring out what happened to those steering currents and why may be key to understanding future storms. He expects the winds to return to normal in a few years. The bad news is that by the end of the century, under current climate models, researchers expect more high-pressure anomalies and a greater chance of collapsed steering winds. Harvey the Black Swan could morph into a storm of our future.